Okay. Yeah, okay. In the same website, I'll put recordings of the Zoom meetings. So here's how I think this might be useful. Watch the screencast at the beginning of the week. Then go to the book and sort of read through the chapter. Maybe not read through it in great detail, but sort of glance through it and see that the things you heard about in the screencast, you also can find in the book. And then start doing the log kappa problems. Now, if you get stuck, then, well, I think I'll give you some suggestions of what you can do if you find that one of the log kappa problems, you're stuck on it. You can't quite figure out what to do. So you go to that channel. It's this channel. You click on playlists. I think there might be two playlists. There's one playlist which should say summer 2021. There probably will be another playlist which says Zoom meetings, which will be the recordings of the Zoom meetings. Now, if you click on this playlist, you'll get a list of videos, screencasts, which you can start running. I'm afraid there might be an advertisement at the beginning of the video. I couldn't seem to get YouTube to stop putting in that advertisement, but just click on, skip the advertisement, and it'll take you to the Zoom meeting. It'll go through equations, derivations, some example calculations, sort of providing an introduction to the subject for that week. And there'll be, I think, 2 per week. Now, if after watching the screencast and glancing through the book, you're at a log kappa problem that you can't figure it out, if you get stuck, then you should be able to find the relevant chapter or the relevant section for that week in the textbook. Or another choice is there are some online lectures which are in log kappa. So if you open up the folder for the online lectures and find the week number that we're working on, there'll probably be multiple online lectures. And you can hopefully find the one which is relevant to your question. And then after you watch that, you should have the necessary information to go back to doing the homework problem. Now, there's another good way to get help on the homework, and that's to use the discussion board. So I don't know how many of you have used log kappa before. It may take you a little while to learn how to use it if you haven't used it before, but it's pretty easy. In any case, you can click on a little dialog button and submit a question to the discussion board, and you can hope then that somebody else will answer your question. Don't ask a question at the last minute, because if you ask a question, an hour before the homework's due, well, maybe nobody's going to be looking at the discussion board. But if you're working on this 2 or 3 days before the homework is due, you come back a few hours later, or maybe the next day, somebody may have answered the question and given you some suggestion how to proceed with the problem. All right, so I'll start looking at those integrals. Let's see if there's anything more asking on the quiz question. Are the screencasts found on log kappa? No. They're found on YouTube. You go to YouTube and you search for this title, Physics 234B of Professor Stump. Now, they're just as relevant to physics 184B as they are to physics 234B. The two courses are combined this summer. And then look for the playlists. All right, I don't see any more questions on the chat, so let's take a look at these problems. All right, the first problem is evaluate integral 0 to a, u squared plus a squared to the minus 1/2 du. Now, you'll sometimes have to do integrals in physics 184, 234. And there are several ways to calculate an integral. One way is to use a math method that you presumably learned when you took calculus. If you're a math major, you should be able to do that. Another way is to use Wolfram Alpha, or Mathematica is a computer software which is equivalent to Wolfram Alpha, which can tell you the value of just about any integral you'd ever run into. In fact, you can probably get a free copy of the Mathematica software online if you go to the Wolfram Alpha, the Wolfram website. So the Wolfram website is called wolframcloud.com. www.wolframcloud.com. You follow the directions, you may be able to get a copy of the software that you can use online for the kind of things which we'll have to do in physics 184 or 234. Wolfram Alpha will be able to do it all if you know how to use Wolfram Alpha. Then there's one other method, which is probably the easiest method of all, which is to look up the integral in a table of integrals. And in particular, in the textbook, there's a table of integrals in the end of the book, in the appendix. So I'll show you all three of these methods for part A of the problem. And then you can do the same things for part B and part C. So let's start with method number one. You have this integral. Well, if you think back to when you took calculus, one way to do an integral is to make a change of the variable of integration into some different variable, which will simplify the integrand. And in particular, when you have u squared plus a squared or x squared plus a squared, there's a standard substitution which will help, which is let u be a hyperbolic sine theta. So you should know the hyperbolic sine function. It'll be in your calculus textbook. If you haven't studied it before, you can look it up in the index of your calculus book. U and a kind of go together. So you could write u is a times something. Where when you have u squared plus a squared, as you're going to see in a minute, the useful substitution is let u be a hyperbolic sine theta. So you start out with a variable u. This is a pure math problem, so u isn't really defined as anything. It's just a number which goes from 0 to a. You replace it by a different variable, theta. Now, what we have here is some function times du. So we have to take du is a hyperbolic cosine theta d theta. So again, if you know your hyperbolic functions, the derivative of hyperbolic sine is hyperbolic cosine. So the differential of a sine theta, a sine hyperbolic of theta, is a cosine theta d theta. Now you also have this function, u squared plus a squared, actually to the minus 1/2. But let's look at u squared plus a squared to the 1/2, the square root of u squared plus a squared, making this substitution. Well, then I'll have a squared, and I can pull out a factor of a from the square root, and I'll have a squared hyperbolic sine squared theta. So again, I pull out the factor of a. What I'm left with is a square root of 1 plus hyperbolic sine squared. Now, if you know your hyperbolic functions, that's a hyperbolic cosine theta, because hyperbolic cosine squared minus hyperbolic sine squared is always equal to 1. There's a more familiar identity like this for the trigonometric functions. I'm sure you remember probably from high school trigonometry, sine squared plus cosine squared is equal to 1. Well, those are the trigonometric sine and cosine functions. For the hyperbolic sine and cosine functions, cosh squared minus sinh squared is 1. Here I have 1 plus sinh squared, so that's cosh squared. Take the square root, that's just cosh. So you see, this is going to give me something simple, because the du has a factor of hyperbolic cosine theta, and the function here gives me a factor, remember it's 1 over that, 1 over hyperbolic cosine, so those are just going to cancel out. And all I'm going to have left is the differential of theta. Now, of course, I have to be careful about the limits of integration. U goes from 0 to a. What are the limits on theta? Well, u equals 0, if I look here, corresponds to theta equals 0. The hyperbolic sine of 0 is 0. It's just like the ordinary trigonometric sine of 0 is equal to 0. So you've got a scientific calculator which will have hyperbolic functions and inverse hyperbolic functions. If you use your scientific calculator and calculate the inverse hyperbolic sine of 0, you'll find it's 0. So the integral goes from u equals 0. That means the theta integral goes from theta equals 0. And then the other end of the integration is that u equals a. Well, if u is equal to a, then hyperbolic sine is equal to 1. So theta is the inverse hyperbolic sine of 1. We call that the arc sine hyperbolic. And just not to have to write that over and over again, let's just call that alpha. So now we go back to I1 and we make these substitutions. And what do we have? Well, we have I1 is the integral 0 to a du over the square root of u squared plus a squared. That's the integral from 0 to alpha, a hyperbolic cosine d theta over a hyperbolic cosine. The numerator cancels the denominator. All I'm left with is d theta. Well, the integral d theta is theta. But you have to remember to evaluate at the upper end point minus the lower end point. So we have theta evaluated at the upper end point, that's alpha, minus the lower end point, that's 0. So this is just alpha. And what was alpha? Alpha was hyperbolic sine, arc hyperbolic sine 1. So I1 is the inverse hyperbolic sine evaluated at 1. And now use a calculator. Because when you give an answer to ln kappa, you have to give it a number. You have to give it a decimal number with 2, 3, 4 significant figures, something like that. So if you get out your calculator, if you have a scientific calculator, it'll have the arc hyperbolic sine, or sometimes it's called inverse hyperbolic sine, evaluated at 1. You know, you punch in hyperbolic sine 1. Has to be the inverse hyperbolic sine. So that's the calculation of I1 using math method. Using pure mathematics. If you're a math major, you probably know how to do this. probably good at doing this if you're a math major. If you're planning to do science, physics, or engineering or something, there are more modern ways to calculate integrals rather than just use pure mathematics. Now, you know, if you were taking a course on calculus, your professor would probably forbid you from using any of these other methods because they want you to learn how to use the math method. But since this is a physics course, all we really care is that you have the answer. So you can use one of these other methods. And let's go on to method number 2. So it's the same integral. Method number 2 is to use Wolfram Alpha. Now, I suppose all science and engineering students know how to use Wolfram Alpha or are familiar with using Wolfram Alpha. You log on to this website, wolframalpha.com. You don't have to log in. You don't have to have an account there. You just use your browser to go to wolframalpha.com. There'll be a place to type in a question. Okay, you type in the question. What you would type, you have to know the language. So the language is pretty easy. If you want to know the integral of 1 over the square to u squared plus a squared, you just say integrate 1 over the square root of u squared plus a squared with respect to u. And you type that into the browser and hit return, and it'll think for a while, and then it'll give you an answer. It looks like this. This I actually did using Mathematica, but Mathematica is the same program as Wolfram Alpha. It'll give you something that looks like this. Minus 1/2 the log 1 minus u over the square root of u squared plus a squared plus 1/2 the log of something else. Now, when it says log, you have to kind of understand the lingo. Log means natural log. The natural log, the log base e. So don't get it mixed up with log base 10. Now you can actually simplify this a bit. If you remember from high school, let's call this A and we'll call this B. This is the log of A minus the log of B. Well, if you think back to your course on algebra 2 or something like that, log of A minus log of B is the log of A divided by B. So we can combine these two logarithms. This function, this is a function of u, so this I of u, but they both have a factor of 1/2. So I have 1/2 log this quantity divided by this quantity. And if you do a little bit of algebra, you'll have the log squared of a squared plus u squared plus u over the square root of a squared plus u squared minus u. This step isn't absolutely necessary to get the answer, but it'll make it a little simpler. Actually, you can simplify this even a little further. If you multiply and divide by square root of a squared plus u squared plus u, then in the numerator, you'll have square root of a squared plus u squared. In the denominator, you'll have a squared plus u squared minus u squared. Namely, you'll just have a squared. Now, remember, 1/2 the log of something is the log of the square root of that quantity. We had this quantity squared. So this would be the log of the square root of a squared plus u squared plus u, plus some constant, which we don't care about. So, again, if you're a math major, if you're good at mathematical functions, you can simplify this a little bit. You'll see in a few minutes why I wanted to write this down. These steps are not really necessary once you've got this answer. This is the only part which is actually absolutely necessary to get from or involving pure mathematics. Now, what this command gives you is not this integral. It gives you what's called the antiderivative. So you'll have a function of u, which is the antiderivative for 1 over the square root of u squared plus a squared. To get the integral, you have to evaluate the antiderivative at the upper endpoint minus the antiderivative at the lower endpoint. So this antiderivative is still a function of u. I1 will be that function evaluated at a minus that function evaluated at 0. Now, if we look at these two terms, if I set u equals 0, this logarithm is 0 because it's the log of 1. If I set u equals 0, this logarithm is 0 because it's the log of 1. So I of 0 is just 0. Now, if I take this form and I set u equal a, you see what I'll have? I'll have 1/2 log. I'll have a factor of a everywhere, so that all the factors of a will in fact cancel out. I'll just have the square root of a squared plus a squared. That's the square root of 2a plus 1a. So I have the square root of 2 plus 1 in the numerator, square root of 2 minus 1 in the denominator. And again, now you need your calculator. Now you might say, well, the answer that I got using the math method was some inverse hyperbolic sine. The answer that I got from Mathematica was some logarithm. Well, the inverse hyperbolic sines are related to logarithms. So the arc, sine, hyperbolic, these two things are in fact equal. So that's method number 2, use Wolfram Alpha. And now, finally, method number 3. Use a table of integrals. And that's the simplest of all. Most engineering majors will get used to using tables of integrals. You know, you probably own a book which is called a table of integrals. If you don't own a book called a table of integrals, you can go to google.com and type into google.com a short table of integrals. And it'll take you to a website where they have a bunch of integrals written down, and you just have to find the integral in that list of integrals. So you can get a table of integrals online if you don't actually have a copy of table of integrals that you need as an engineering major. But actually, for a simple integral like this, you can find it in the textbook. So in the textbook, if you look in Appendix A, page A6, Appendix A is a math summary. If you're a little bit rusty on your math at some point in this semester, in the summer school, read through Appendix A. It's got most of the math that you need kind of summarized. And in particular, equation A71 is exactly the same as this integral. Well, not exactly, but here, if you look up equation A71 in your textbook, here's what you'll find. You find the integral 1 over the square root of a squared plus x squared dx. Well, see, that's the same as this, except instead of using the variable u, it's written in terms of the variable x, but that's the same. Now, of course, this is just an indefinite integral. This is the antiderivative. But this is, this is the equation in the back of the book. So you'll immediately see this is the log of x plus the square root of a squared plus x squared. Or really, to be precise about it, it's the absolute value of x plus the square root of a squared plus x squared. And if you'll go back here, that's what I had here. X plus the square root of a squared plus x squared. So by hook or by crook, and I suppose the easiest way to do it is to use a table of integrals. You'll have the log, you'll have the integral. It's the log of x plus the square root of a squared plus x squared. But that's not the integral. That's not I1. That's the antiderivative. I1 is that quantity when x is equal to a minus the same quantity when x is equal to 0. Oh, by the way, when you write the antiderivative, sometimes you have to write an unknown constant. But of course, that unknown constant will cancel out. When you take I at a minus I at 0, you'll have plus c minus c. So the unknown constant will just cancel out. You'll have the log of a plus the square root of 2a minus the log of a. You can combine those two logs. So, again, your scientific calculator will calculate these logarithms for you. I mean, in the homework problem, a is given a value. I haven't been putting in a particular numerical value for a. In fact, I1 doesn't even depend on the value of a, but I2 and I3 do. But anyway, in the homework problem, there'll be a value of a that you're supposed to use. And so you just calculate this logarithm function for a, x equals a, minus the logarithm function for x equals 0. So that's kind of way to calculate integrals that you can use throughout the semester. Any of those three methods. And I think actually all three of the integrals for this problem are in the textbook. All right, so any last minute questions? That's really all I had to say for tonight. This assignment is a pretty short assignment. Most of it's just simple math. Next week, we'll begin to get into more involved problems. And so I'll have another Zoom meeting. I guess it'll be next Tuesday, 2 days before the assignment is due. I'll give you one little piece of advice. If you want to get a high grade in this class, what you should do is try to spread out the homework over a period of several days. If you don't care about your grade, then you can just do the homework the day before it's due. It's going to be due Thursday night. Well, if you start working on it Thursday afternoon and you don't care too much about your grade, you can probably get most of the problems. But it'll be frustrating if you have to have to do all the problems at the last minute. You're going to find that frustrating. But you can probably do it that way if you don't care too much about the total. But if you want to get a good grade, the way to do it is spread it out over 2 or 3 days. Instead of trying to do 15 problems Thursday night, do 5 problems Tuesday, 5 problems Wednesday, 5 problems Thursday. Have them all done in time, and it won't be so difficult. So I don't really have anything more to say. Anybody have any questions? If you have a question, you can just unmute your microphone and speak up.
How do you recommend that we look over the chapter topics, like for the online lectures, to kind of like spread it out across the semester?
I would sort of glance through the chapter, see what's in the chapter, start doing the problems. When you find something that you can't do from your reading of the chapter and you want more information, then you can use the Lon Kappa lecture You can identify what topic it is and watch the lecture. You know, the lectures are short, but there are quite a few of them. So if you just listen to all the lectures in one sitting, it's probably going to take several hours. It depends on whether you like reading or not. You know, some people like to learn by reading the material, but some people prefer to listen to something. So I would say that the screencasts I'm putting on YouTube are not as detailed as the lectures at Lon Kappa, but they should get you started. And they should get you started so that you can actually start doing the Lon Kappa problems. And then when you need to, look up something in the book. But eventually you have to study for an exam. I'm not sure how many exams Professor Naja has scheduled. I think it was 2 exams and a final exam. Take notes so that you have something to refer to in the exam.
You're saying take notes over the YouTube videos?
Over the YouTube videos, over your readings. Yeah. You know, before the first exam comes up, I'll show you how you can use the textbook to study for the exam. I believe that Professor Naji usually lets you use a page of formulas. So you have to know what formulas to write down on your page of formulas. And I'll show you how to do that using the textbook. It's pretty simple. You just go to the end of the chapter, there's a chapter summary. And if you just copy onto your page of formulas the equations that are given in the summary, and you make sure that you're familiar with them all, you'll be well prepared for the exam.
Thank you.
All right, I'm going to end the recording and end the meeting. Well, let's see.